Okay, we shall continue the topic of MOSFETs as active load. In the previous video, we have seen three different cases. So let us try to understand all of three. Suppose if you are looking into the source of a MOSFET with gate and drain AC grounded, the resistance was found out to be suppose if this lambda is non-zero, the resistance is found out to be 1 over Gm parallel with R0. On the same lines, if you have a MOSFET whose gate is AC grounded, and if this source is also AC grounded, if you look from the drain, the resistance was equal to R0. The third possibility was again a MOSFET. You have this gate AC grounded, this drain, and okay, let me not ground this. Okay, let me just discard this. If I have a case something like this, this source is AC grounded. Suppose if this gate and drain are shorted, so this is drain, gate, source. If I look from here, the resistance was R0 parallel with 1 over Gm. This is the case for even for PMOS transistor also. So here we are considering only NMOS transistor. So this is for NMOS transistor. If I repeat the same thing for PMOS transistor, this is PMOS transistor. We know that for a PMOS transistor, always source is at a higher potential. So I am writing it over the top. So if this is AC grounded, if this gate is also AC grounded, if this is your drain, source, gate, looking towards the drain, it is again R0. Again you consider a PMOS transistor. If this drain is AC grounded, if this gate is also AC grounded, if you look from the source, it is 1 over Gm parallel with R0. You have the third category where you have this is again the PMOS transistor. This is AC grounded. Suppose if this is connected to gate and drain are shorted, if you look at from this, so it's again 1 over Gm parallel with R0. So these are the three different possibilities of MOSFET as active loads. So now let us consider some more categories. Suppose if you have a MOSFET which was, let us consider an MOSFET. This is source. Suppose if this source is connected to ground through a resistor RS. If this is AC grounded, we are interested in knowing what is the resistance looking into the drain. We actually had similar type of configuration here. The difference between this and this is, here source is AC grounded, but here is source is connected to ground through a resistor RS. Now we are interested in what is the resistance looking into the drain when the source is connected to ground through a resistor RS. So what we do is, we know that to find the output resistance, we'll connect a dummy source of magnitude Vx. So we will find out what is current Ix. So Vx by Ix happens to be, Vx by Ix is the resistance R out. So let us do the same thing. So what I'll do is, I will connect. Okay, now this is my gate, this is source, this is plus minus VGS. I will connect, this is my Gm into VGS. This is now, we know that this there is a R0 also. Let me connect RS here because this is my source RS. and let me connect a dummy source Vx. The current is Ix. The current is Ix. Now this is current Ix. Of course, that Ix will be get divided here and here. I'm going to have again same Ix flowing here. How about this gate? This gate is grounded. This gate is grounded. So now we have this type of configuration. So what is VGS now? So, or can we write what is the, let us consider this as node A. So this is node A. At node A, apply KCL, write the currents. So is the incoming current is this current are the two incoming currents to this node, and this is the outgoing current. So we know that outgoing current Ix is equal to incoming currents. So let me name this current as IR0, current flowing through R0 plus this GM into VGS. So let me write as GM into VGS. But what is VGS here? Because I know that VGS is this voltage, which is nothing but minus of Ix into Rs. This is minus of Ix into Rs. So what I have now is Ix is equal to, what is this IR0? IR0 is the current flowing through this resistor. Shall I write it as potential difference across this resistor, which is Vx minus Ix into Rs divided by R0? So this I can write it as Vx minus Ix into Rs divided by R0 plus, what is this? It is Gm into minus of Ix into Rs, minus of Ix into Rs. So let me rewrite this in the next page. So maybe what I do is, let me rewrite the entire thing, because that term will be missing. Just a minute. Okay, let me rewrite it here. So this is my, okay, we know that this will get grounded. Okay, this is your gate. This, you can see this gate is grounded. Let me rewrite the same thing. So this is gate grounded, this is source, this is plus minus VGS, this is GM into VGS, this is R0, and I have a dummy source plus minus Vx, this is the current Ix, and I have this resistor Rs, the same current If flows here. So this is my node A. So in node A, what is the current? Ix is the living current. The entering current are Gm into VGS, and one more current is IR0 plus IR0. So we can write VGS as equal to minus Ix into Rs, and IR0 as equal to Vx. This is voltage Vx. What is this voltage? This voltage is Ix into Rs. It is now minus Ix into Rs. So this is the potential difference across this divided by R0. So let me substitute that here. This is now equal to, so is it not minus of Gm into Ix Rs plus of Vx minus Ix into Rs divided by R0. If I simplify this, will it not become minus Gm into Rs into R0 into Ix plus Vx minus Ix into Rs, and this is Ix into R0. So let me take the LCM. That R0 is multiplied here. If I multiply that R0 to this, it is so and so. So shall I take out all terms consisting of Ix onto one side? So I can write it as Ix. One term is R0. The other term is plus Gm R0 Rs, one more term is Rs is equal to Vx. So this is the equation I have. You can see this is IR naught, and when it comes here, this is nothing but Gm R naught Rs, and this is next term Rs. So can I rewrite it as Vx by Ix as equal to, let me write it as R naught plus, shall I take Rs outside from this common? Is it not Gm into R naught? Is what? R out looking into the, so this is what? This is corresponding to, this is AC grounded, you have, this is Rs, you are looking into, this is source, drain, and this is gate. If gate is AC grounded, if you are looking into the drain with source connected to Rs, of course source connected to ground through resistor Rs is nothing but the resistance of this R naught plus this Rs will be seen at this point as Rs into 1 plus Gm R naught. So this is nothing but R naught is this resistance and plus Rs into 1 plus Gm R naught, meaning this resistance at this point will be seen by 1 plus Gm R naught times Rs is the value of R out. Now let us see one more type of configuration where we have something like this. Now what you have a source, and we know that if you ground this, if you AC ground this, the resistance is 1 over Gm parallel with R naught. The modification to this is, now I am not connecting it to AC ground immediately, but it is through a resistor RD. So here drain was directly grounded, drain is now grounded through a resistor Rs. Now I am interested in what is this resistance looking into the source, Let us see what happens. Shall we again redo the same thing of writing this AC equivalent and then so on so. So this is my gate. This is, of course, what I have to do is I have to connect a dummy source Vx and find out what is Ix. Vx by Ix happens to be the resistance looking into this, some resistance R. So is this my source? Let me connect a dummy source here. Is this Vx? Is this Ix now? Shall I write it as Gm into Vgs, and is this my R naught? Is this connected to resistor and that is in turn going to ground, correct? So this is R naught, this is so and so. Now if this is Ix, does the again same current flows through this resistor also, because there is no other way, whatever current goes here it will be going there. So now can I now write at this junction A, KCL at node A, Let us see what happens. So is the recording going on? Yes, it's there. Now what is the current that is entering this node? Ix. What is other current? Is one more current is entering also. Okay, what is this? Okay, this is also, let me ground this. This is plus minus Vgs. Okay, let us write this. So this is one current that is entering. Is this is also entering? It is not. Is it not Gm into Vgs? And let us assume that this is also an entering current. So all the three currents are entering. Let us name this as IR naught. So is it not IR naught? Since all the three currents are entering and none of the current is leaving, it is Ix plus Gm into Vgs plus IR naught is equal to 0. But what is Vgs as per this circuit? this is VGS, so this is Vx. So this is actually plus minus. Is it minus Vx? Then what is IR naught? Since we are assuming this has higher potential, this has lower potential, it is the potential difference across this R naught by R naught. So what is this higher potential? It is Ix into Rd. Ix into Rd, and this is actually minus Vx. That is this minus this potential is Vx, so it is minus of Vx divided by resistance R naught. So let us substitute it there. So I have this as Ix, this is minus Gm into Vx plus, shall I write it as Ix Rd minus Vx by R naught is equal to 0. Let me rewrite it here. I have it as Ix minus Gm into, I am just rewriting that, plus Ix into Rd minus Vx by R naught equal to 0. Let me take the LCM and all those stuff. Will it not becomes Ix into R naught minus Gm into R naught into Vx plus Ix Rd minus Vx is equal to 0. Shall I now make it Vx? What all things are common? 1 plus Gm R naught. Of course it is minus, and if this goes there, it's again minus Ix. Let me take that as common factor. What else you have? You have R naught plus Rd. So then what is V? Okay, this minus will go off. What is Vx by Ix? Is it not R naught plus Rd by 1 plus Gm R naught? So let us slightly rearrange this. So shall I write it as R naught by 1 plus Gm R naught plus Rd by plus Gm R. This is small R naught, correct? See, I'm just separating this out. So this is common. Let me make this R naught by 1 plus Gm R naught, and this is Rd by so and so. So in this form, it doesn't give me a sense of that value. Now, if you can see this, shall I take out this 1 compared to Gm R naught, because Gm R naught is very large value, plus 1 doesn't have any meaning. So then take out, shall I just cancel this R naught with this R naught? So now, does this equation, looking into the source with this drain connected to ground through a resistor Rd, will it not look like as 1 over Gm? Let me write it. That resistance is 1 over Gm plus Rd divided by intrinsic gain of the transistor. So if you neglect this one, is it not Rd by Gm into R naught? What is to be understood here is if it is AC grounded, suppose if the source is AC grounded, the drain is AC grounded and gate is AC grounded, if you look into the source, it is 1 over Gm paired with R naught, or you can approximately write it as simply 1 over Gm. Now, this is a different case where you have the drain is grounded through a resistor Rd. In such case, the resistance looking into the source is, again, this term is still there. You can see this term is still there, that is 1 over Gm, but there is one more term coming. So that term is this resistance Rd divided by the intrinsic gain of this, that is 1 plus Gm R naught. This is the resistance. That's what is seen here. See here, 1 over Gm plus Rd divided by 1 plus Gm R naught. Just to summarize, just to summarize, so let us see what happens here. This is AC grounded, this is source, this is also AC grounded. If you look into this, what is the resistance? Because this is drain, it is R0. Now you consider the same case, but again you are looking into drain, but this is connected to ground through a resistor RS. What is this resistance now? The looking into the drain, it's again R0, but plus RS into 1 plus GM R0. So this is my intrinsic gain. You can treat this as R0 plus RS into GM R0, because compared to GM R0 this one is negligible. So this what I call it as intrinsic gain of the amplifier. So this resistance will be seen at this point as intrinsic gain times RS. On the same lines, we have also seen that if you have a resistor, suppose if this is AC grounded, so don't consider resistor. If it is AC grounded, if this is also AC grounded, if you look into the source, is it not 1 over GM approximately? 1 over GM paired with R0 is almost 1 over GM. Now you consider a case where you have this drain connected to ground through resistor RD, again ground this. If you look into the source, what is the resistance? The same term is still there. This is still there. But what is this term will be represented by? Will be seen at this point as RD by 1 plus GM R0. Here it was actually multiplied by intrinsic gain times. Now it is divided by intrinsic gain times. So it is 1 over GM plus RD by GM into R0. So this is the resistance looking into the source with drain connected to AC ground through a resistor RD. So now with this we can have still more different combination. Of course this is true for even PMOS transistors also. So what I mean to say is, assume that you have a PMOS transistor. If you have a RD connected here, if this is AC grounded, are you not looking into the source now? Are you not looking into the source? Then what is the resistance? The resistance is 1 over GM plus RD by GM R0 approximately, or to be exactly it is 1 plus GM R0. On the same lines, if you have a PMOS transistor, if this is AC grounded, if you have a resistor RS, and if you look into the drain of it, if this is AC grounded, if the source is connected to RS and this is in turn connected to AC ground, then what is the resistance? It is R0 plus RS multiplied by 1 plus GM R0. 1 plus GM R0. Okay, fine. Now let us consider this case. Do you have a are you now looking into drain? Let me just AC ground it. So let us consider, instead of having RS, let me consider this. Let me AC ground this. Let me AC ground this. This is, let me name it as M2 M1. M2 M1. See now, so do you have a configuration where gate and source are AC grounded? Then looking into the drain of this, what is the resistance? We know that resistance is R02. Now, does this become the resistance R02 as it was where here? So this RS is now represented by R02. Now can I write it like this now? So now can I write this as something like this? This is AC grounded. Are you now looking into M1? This is R02. Because you are AC grounding this resistance is R02. Then what is this resistance? Is it not R01 plus this resistance R02 multiplied by intrinsic gain of this GM1 R01. Correct? See, you are looking into drain, it is R02. This is effectively represented by R02. Then what is the resistance looking up from this, okay, towards the drain of this M1? Is it not R01 of this plus this resistance multiplied by intrinsic gain of this? On the same lines, if I am having same type of configuration where you have again looking into drain, this is AC grounded, but let us consider I have a PMOS transistor. Now source is seen. So what is the resistance looking into the source of this? Is it not approximately, okay, let me name it as M2. Is it not approximately 1 over GM2? So then does this will be replaced by 1 over GM2? Because these two are same. So now if it is replaced by 1 over GM2, then what are the resistance here? So now is it still same R0 1 is there? Because this is same. So what is this now? So this is no more R02, now it is 1 over GM2. How about this? This remains same, 1 over GM1 R0. Because now I have replaced this resistor by 1 over GM2. So let us take one more case where you have again same type of configuration, but this is NMOS transistor, but it is diode connected. So let me now again have it as AC ground. I am looking into this, so let me name it as M1, M2. So what is the resistance looking into this now? Looking into this, is it not approximately 1 over GM2? Because we know that when you have a diode connected load, the resistance looking into the drain is 1 over GM2. So then what is this overall resistance looking into this? Is it not same as this value? Is this is R01 plus is this is 1 over GM2 and is this is intrinsic gain of this? So these two configuration will give same resistance looking from the drain of this, whereas for this particular circuit the resistance is R01 plus R02 multiplied by intrinsic gain of this, Let us consider looking into the source. So far we looked into just the drain. Now let us start looking into the source of the transistor. So now let me consider this is now source, this is now source. Now let me look into the source. Let me AC ground this, let me AC ground this, let me AC ground this also. So now let me name it as M1, this is M2. So what are the resistance looking into the source? Is it not 1 over GM1? Is 1 over GM1 plus what is this resistance now looking into the source of M2? Is it not 1 over GM2? So what is this overall resistance looking from here? The overall resistance looking from here is 1 over GM1 of this transistor, and this resistor at this point will be seen as 1 over GM2 divided by intrinsic gain of this, that is 1 over GM1 R01. Correct? That's what we saw in the previous case. Can you see it? So was this when you are looking into the source with this RD connected at the drain, was it not 1 over GM of this and RD divided by intrinsic gain of this? So in place of RD I have 1 over GM2. In place of RD I have 1 over GM2. Now the same thing I can rewrite it using You can see the bottom remains the same. So now you are again looking into source. Let this be M1. Let me AC ground it. Let me AC ground it. This is also AC grounded. Now shall I connect M2, which is the drain. Now looking up here, how much is the resistance which is there in place of this RD now? So don't you have this resistance is R02? Then what is this resistance? So is it not the same 1 over GM1 plus this was actually RD which was offered by this MOSFET. So what is the resistance offered by this M2 now? Is it not R02? Because the resistance looking towards the drain is R02 divided by same thing. I can see it is 1 plus GM1 R01. The difference between these two circuits is this, which was the RD representation. Here it was 1 over GM2, but here it is R0 because looking into the drain. So what is the third configuration? Third configuration is this. So shall we write it as third configuration as something like this now? It is still a PMOS. You have a diode connected load. Shall I ground this? So now I am looking into source of M1, M2 is so and so. So what is the resistance looking up now? So what is the resistance looking up? Is it not again 1 over GM2 in parallel with R02? Is it approximately 1 over GM2? Then what is the resistance? So is it not the same term here? 1 over GM1 plus what is in place of R02? What you have? It's 1 over GM2. Is it not 1 over GM2 divided by, it's the same term, that is 1 plus GM1 into R0. So now the resistance 1 over GM2 will be seen at this point as 1 over GM2 divided by intrinsic gain, that is 1 plus GM1 R01 plus its own input impedance, that is GM. Looking into this, what is the impedance? 1 over GM. That's what is this term. So we have these different categories. So let me just summarize the entire gamut of resistors we have, active loads we have. So let me just say this is my, so let me write it for only NMOS. So will be, all these are NMOS transistors. Now let me have, this is AC grounded. So let me look from the drain. If I look from the drain, of course in all these cases lambda is considered to be non-zero. Lambda is considered to be non-zero. Now this is, you are looking towards drain. It is now source is AC grounded, this is AC grounded. The resistance is R0. Okay, assume that this is M1. This is R01. Now let us have a case where you have this as a resistor. RS is connected to source. So then what is the resistance now? The resistance now is R01 plus RS into 1 plus GM1 R0. Correct? Now you consider the case where you have something like this. This is again AC grounded. You have this now. So let me name it as, this was M1. Okay, let me name it as M1, M2. Let me AC ground this also. Then what is the resistance now looking into this? Is it not R02? So then what is overall resistance here? Is it not R01 plus R02 into 1 plus GM2 R02? Sorry, this is GM1 R01 because it is this intrinsic gain we should consider. We rewrite, it is R01 plus R02 into intrinsic gain of this 1 plus GM1 R0. Now let us consider this again, looking towards the drain. This is AC grounded. You have this as PMOS. Let me AC ground this, AC ground this. So let me say this as M2, this is M1 looking into this. So what are the resistance? If I just take the resistance of this over here, so is it not R01 plus, what are the resistance looking down here towards source? Is it not 1 over GM2? Is it not multiplied by GM1 R01? It is GM1 R01. Now what is the next category? Next category would be ground this, look towards again the drain, but this is now diode connected. So this is M2, M1. Is it not same as this? Is it not same as that? If you look from the source, so now let us take the same type of thing. You are looking into the source. So this is AC grounded, this is AC grounded. So what are the resistance? It's approximately 1 over GM1. So let me say it as M1. Now you again have, this is AC grounded. Let me say this is M1. Now it is, let us say there is a RD connected. So what are the resistance now? Is it not 1 over GM1 plus RD divided by intrinsic gain GM1 R01? I'm just summarizing. What is this now? Again you are looking into the source. You have a PMOS load. Let me say it as M2. This is AC ground. This is M1. This is also AC ground. So what are the resistance looking up towards the drain of this M2? Is it not R02? So what are the resistance? Is it not 1 over GM1 plus R02 divided by 1 plus GM1 R02? Now let us consider a case where you have, this is AC grounded. Let us consider this as source. This is M2. This is again AC grounded. Let me say this is also AC grounded. You are looking into this. So this is again source. What is the resistance? Is it not 1 over GM1, because this is M1, plus what is this resistance? It is 1 over GM2 divided by intrinsic gain of this 1 plus GM1 R01. Last category is, again you have same NMOS. Okay, this is so and so. Now let us consider, okay, PMOS transistor. This is a PMOS transistor. Let me have a diode connected load. So this is now M2, M1. This is also AC grounded. If you look at the source of this M1, if I look at the source of M1, is it not the same resistance here? So this resistance is same for this as well as for this. See now this is 1 over GM1 plus, is the resistance looking up here is 1 over GM2 divided by the intrinsic gain on this. That's about different possibilities of active loads. We'll see how do we use all these active loads in all different amplifiers. It can be CG, CC, CD, cascode, or we're going to see in other MOSFETs amplifiers also. Thank you.